shall be discussing today fast Fourier transform. Basically, it is the computation of discrete Fourier transform in an algorithm where the computational burden will be reduced. As we discussed last time, this fast Fourier transform can be implemented for design of an FIR filter. So, we will see how that can be done sorry, how that can be done at the end. So, let us see the discrete Fourier transform, the expression for discrete Fourier transform, and then how this faster algorithm can be implemented. We have the expression for xk as xn wn and k, okay, n varying from 0 to n minus 1. All right. Now, let us have say the points like this. Let us take 8 points 1, 2, 3, 4, 5, 6, 7, 8. Let us pick up the even terms and odd terms and group them together. So, this is x 0, x 1, x 2, x 3, x 4, x 5, x 6, x 7. If I bring these the order will be x 0, x 2, x 6, sorry x 4 and x 6. This will be the even terms. If we pick up the odd terms, so I will get x 1, x 3, x 5, x 7, right. We have made two groups. Again, out of these 4 points, if we pick up alternate terms, then the ordering will be x 0, x 4, x 2 and x 6. All right. X 0, see in this sequence x 0, then alternate term will be x 4. Similarly, next one will be x 2 and x 6. Similarly, from the odd sequence, if we again segregate into alternate terms x 1, x 5, x 3, x 7. This will be the terms. Now, after breaking it into two groups of 2 each, 2 elements each, we cannot go down further. So, this will be our smallest element. Now, let us see how this helps, this kind of breaking down helps. Once again, I write xk as, if I now break it up into even and odd terms, it will be say x 2 r w n 2 r k plus x 2 r plus 1 odd terms w n 2 r plus 1 into k. Do you all agree? Where r varies from 0 to n by 2 minus 1. Okay. So, this can be written as x 2 r w n. Now, this 2 can be brought down here, plus x 2r plus 1 W n by 2 r k into W n k, again r varying from 0 to n by 2 minus 1, r varying from 0 to n by 2 minus 1. Okay. Now, this I write as g k plus, this is similar to g k, all right, and multiplied by W n k, I call it h k. Okay. So, it is basically half the number of points. If you have an 8-point sequence, then this is basically a 4-point sequence computation. Here also it is 4-point sequence. If we show it diagrammatically, it will look like this. I have given x 0, then x 2, x 4 and x 6. These are the 4 points that will generate G, okay, and I get output as G 0, G 1, let me use the same bracket, G 2 and G 3. Okay. And similarly here H, which is having inputs like x 1, x 3, x 5 and x 7. I will get H 0, H 1, H 2, H 3. All right. Now, I am combining G and H in this mode, that is G plus H multiplied by this quantity will give me corresponding x k. So, let us do that. So, it looks like this. G plus H when k is equal to 0, W n 0 is 1. So, H 0 plus G 0, G 0 plus H 0, this is W n 0. So, this is multiplied by W n 0, and in the signal flow graph you use this as addition, okay, when they are going inward. So, this will be x 0. Similarly, H 1 what should be x 1 like? G 1 plus W n 1 into H 1. So, this has to be multiplied by W n 1. Okay. N is 8 in this example. We have taken 4-point sequence in each of these. Total it is an 8-point sequence. So, similarly, H 2 has to be multiplied by W n 2. Okay. And then added with G 2, that will give me x 2. H 3 is to be multiplied by W n 3, then added with G 3, that will give me x 3. It is fine. What about x 4, x 5, x 6, x 7? Now, you see W n, say W 8, n is 8 in our case, W 8 5, W 8 4, how much is it? -1. W 8 5, minus W81. All right, I can write this as W84 into W81. So, all of them after 4 will be negative of the previous values. So, W86 is minus W82 and W87 is minus of W83. Is that all right? Therefore, I can have the same combinations mind you here here for computation of k there is nothing like k is not beyond 4, k cannot be computed beyond 4, but you see here when I put different values of r, it is basically G0 minus H0, that gives me a negative sign, that gives me x4. All right, because why? Because GK is also periodic. It is a 4-point sequence, so after every 4 points it will be periodic. So, G5 is same as G1, G6 is same as G2 and so on. So, it is only this multiplier which will have negative signs. Sorry. So, here G0, if I club with H0, what should be the sign? X4 will be G0 minus H0. Okay. So, G0 minus H0 will be X4. Similarly, X5 will be G1 minus W81 into H1. Okay. So, when it is coming downward, there will be a negative sign. All right. So, I will put a negative sign in this, that is to be multiplied with H, when we are considering the bottom layer. All right. H0 multiplied by minus 1, H1 multiplied by minus 1 into Wn1, that is Wn5. So, this is nothing but Wn, W84, W85, this is W86 and this is W87. So, this looks a little jumbled up. I will draw it a little more neatly, only this part. So, it will be looking like this. The 0, 1, 2, 3, 4. So, this is Wn0, W80. This is W81. Similarly, this is W82 and this is W83. And this one, this is H0, this is, so this is W83, I I will write here so that it is not confused. This is W84, this will be W85, this will be W86 and this will be W87. I think you can all complete this structure. Okay. So, these are the G's and these are the H's, G0, G1, G2, G3, H0, H1, H2, H3. So, they are to be added like this. I will get X0, X1 up to X7. See, these are 4-point butterflies, we call them butterflies. By the same logic, G and H can also be computed from say 2-point sequences. So, if we break it down further, it will be X0 and just some time back we have seen has to be coupled with X4, all right, and then what will be these values? By the same logic as we have done earlier, for an 8-point sequence you had W80, W81 and so on. So, you will have in this case W80, W84. Okay. Sorry, W80 and W84, because I am skipping just the previous step where you have 2-point sequences combined in the similar manner. I will just show one of them. See, these two pairs, if they are to be combined to get the 4-point sequences, it is like this. Similarly, for the other group. Okay. So, this particular intermediate step I am skipping. So, previous to that, if we go down, then it will be W80, W84, here it will be W80 and W82. Okay. So, this will be W83 and this will be W84. Okay. Is it not? Very similar to the previous one. You have W80, W81, W82, W83 and the horizontals were W84, 5, 6, 7. Similarly, here it will be W80, W82, W83, W84 and the horizontal ones will be the other ones. And then this one will be X2, X6 and so on. I am skipping the other 4, all right. What will be the values of this? This will be X0 plus X4, W80 is 1. So, this will be X0 plus X4 and this one will be X0 minus X4. So, when you come down to the lowest level, it will be just addition and subtraction of 2 numbers. Similarly, it will be X2 plus X4, X2 minus X4. Okay. So, it is this quantity which is to be again multiplied by respective values. Okay. Let us take an example. Is this all right? X0, X4, X2, X6, yes, thank you very much, okay, and so on. So, let us take an example and then work out one problem, it will be clear. Okay. Let us take a sequence x n equal to, you suggest a sequence, say 2, 1, minus 1, okay, minus 3, 1, 1, 2, I am taking very simple values 1, 2, 3, 4, 5, 6, 7, okay. In between I can put 1, 0 and 1, okay. This is a sequence. So, what will be the first stage of computation? It will be arranging the terms in this sequence. So, it will be 2, next it is 4, 0, 1, 2, 3, 4, 0, all right, have a butterfly, then this will be 2 and this will also be 2. Next minus 1 and 2. So, this will be 2 minus 1, 1, minus 1 minus 2. So, this will be minus 3. Okay. Next, what will be the other values? 1, x 1 and 1 and 5. Is that all right? So, 1. Is that okay? And then minus 3, correct me if I am wrong, minus 3 and 1. So, what will be these values? 1 plus 1, 2 and 0, minus 3 plus 1, minus 2, minus 3 minus 1, minus 4. Correct me if I am wrong. Is that all right? Next, we should combine these two. So, let me draw it. Okay. Let us draw horizontal lines first, that will be easier to trace. So, this has to be paired with this, okay, and this has to be paired with this. This has to be paired with this. This has to be paired with this. What will be the multipliers? This plus this, 2 plus 1, okay. So, 3, and then what should I do with this? This is that all right? This is 2 plus 1, 3, and this one will be 2 minus 1, 1, and what about this? What should I multiply with? What should I multiply with? When we are taking 2-point sequences, W41, no? Should it not be W41? W82 means W41. So, W41 is minus j. Okay. So, I will write this one as 2, this is minus 3 into minus j, that becomes plus 3j. Is that all right? If this is 2 plus 3j, then its counterpart will be 2 minus 3j. Okay. Once again, you draw the lines. So, this one will be clubbed with this with this, this with this and this. So, this one will be 2 minus 2 0 and 2 minus minus 2. So, 4, is it all right? And then 0, this is 4 multiplied by minus j, all right. So, 0 minus of 4 into minus j, that becomes plus 4 j, is that all right? So, this one will be minus 4 j. In the next stage of computation, this one will be clubbed with this, okay. So, this will be, first one will be always with a constant 1. So, 3 plus 0 3, next this one with this one, next this one with this one, and this one with this one. What will be this value? 2 plus 3j into 4j into how much? Now, it is W81, is that all right? W81 is minus 45 degrees. So, minus 0.707, sorry, the real part is positive. So, I will write 2 plus 3j, I leave the computation to you, plus 4j into 1 by root 2 minus j by root 2, okay. This one, it will be 1 plus, third one 1 plus 4 into how much? 4 into minus j, and this one will be 2 minus 3j plus minus 4j into minus 135 degrees. So, both are minus. So, minus 1 by root 2 minus j by root 2, whatever be that you compute. Similarly, you can find out for these 4, all right. Draw these lines. What should this be multiplied by? This was basically W0, W81, W82, W83, then this would be W84 means minus 1. So, it will be 3 minus 0, it is also 3, then this one, it will be 2 plus 3j minus 4j into the same thing, is that all right? 1 by root 2 minus j by root 2. Similarly, this one, third one and fourth one. So, this one will be 1 plus 4 into what will be this? Plus j, is it not? And this one, last one will be 2 minus 3j minus 4j into, it will be plus 45 degrees. So, I will write here 1 by root 2 plus j 1 by root 2, okay. You will find the symmetry in the conjugate symmetry of the values. This is 3, this is also 3. The first one will be always real for a real sequence, and then this point onward you will find this one will be complex conjugate of this. You see here 2 plus 3j, 2 minus 3j, this is plus 4j, this is minus 4j, 1 by root 2 minus j by root 2, it is plus j by root 2. All the signs of the imaginary terms are just opposite here. So, these two will be complex conjugate. Similarly, this is 1 minus 4j, this is 1 plus 4j. As you go towards the central one will be again real. This is 2 plus 3j, 2 minus 3j, this is minus 4j into this. Okay. Check whether you get minus 4j into 1 by root 2, okay, this is plus 1 by root 2. So, this is also complex conjugate. So, by this we have seen that if you can arrange the terms and we start with 2 point sequences and gradually develop it, we can get the output in order. So, what should be the sequence at the input? It is all shuffled. So, how do you do the shuffling if n is very large? For an 8 point sequence you can do it manually, or 16 point sequence you can do it manually. When it is very large, say 256 or 512, then how do you make those arrangements? So, this is in place computation, that is before we start the computation we first of all arrange these terms, and these two will be replaced by these two values. Okay. These two will be replaced by these two. Then again when you take the combination of these two pairs, these 4 will be replacing these 4. So, gradually you keep on replacing the positions by the newer values, and at the end you get the final product. So, how do you replace them? So, what will be the position of the seats in the beginning? So, in place computation, you will find for an 8 point sequence, it is output is 0, 1, 2, 3, 4, 5, 6, 7. What is the binary expression for this? We are going for an 8 point sequence, so there will be 3 digits 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. If you reverse them, reverse sequence, this will be 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1. Now, if you express them in decimal numbers, this will be 0, this will be 4, 2, 6, 1, 5, 3, 7. So, basically this is the shuffled sequence. So, this is known as bit reversal technique. So, you express them in binary digits, then you reverse them and again convert it back to the decimal numbers, you get the reverse sequence. So, you shuffle the data in this sequence, you will get this. Now, what is the logic behind it? If you remember, our binary digits are say 3 digits like this. What we have done is, so this is 0, this is 1, this is the first position, then 0 and 1, the second digit, and then 0 and 1. Okay. So, this becomes 0, 0, 0, then 0, 0, 1. Similarly, this one 0 and 1. So, this becomes 0 1 1 sorry 0 1 0 and 0 1 1. Similarly, here 0 1, okay. Again we are having 0 1. So, this will become 1 0 0, then 1 0 1, then this is 0, this is 1, just the upper one I am keeping as 0, next one is 1, and if I arrange it like this, so it will be 1 1 0 and 1 1 1. So, this is basically the sequence of the digits, the decimal digits expressed in binary form. While realizing it, we are going back from here, we are starting from the last sequence. So, we are combining this 0 with 1. So, then after that it will be this position, next it will be this position, alright. So, basically the reversal takes place in this mode. So, x n 2 n 1 n 0. For example, when you choose the even numbers and the odd numbers, what is the identity of an even number? The last digit will be, last binary digit will be 0. So, you are taking all the zeros together and all the ones together, alright. That means, out of this you are taking these zeros, selecting them first, segregating them first. So, those zeros are taking the first position, alright. Then these ones are coming next. So, in the next sequence you are putting 1 1 1 etc., alright. Then in the second sequence also, out of these the middle, this is a 3 digit number. So, the middle one again you are selecting, out of these zeros, the ones which are ending with zeros, you are selecting the middle ones again with zeros and ones. So, that is how the thing is getting reversed. There is another technique, instead of segregating them in even and odd parts, you can just half them. This is known as, the earlier one is known as decimation in time. Okay. Now, we are decimating in frequency domain, decimation in frequency, that is you keep on halving them. So, you take x 0, x 1, x 2 and x 3, one set. Similarly, x 4, x 5, x 6 and x 7 in the second set. Then again take these two elements, x 0 and x 1 as one pair, x 2 and x 3 as the next pair. Similarly, here x 4 and x 5 and x 6 and x 7. Okay. And then, like the earlier butterflies, you create outputs out of these and then combine in a certain fashion. What should be that? It will not be definitely the earlier fashion of combining them. So, we will see how this can be achieved. We have xk is equal to xn wn nk summated over n 0 to n minus 1. So, if I take into two halves, it will be x n w n n into okay. What we are doing, n is now 0 to 3, all right, first 4 we are taking. So, n varies from 0 to n by 2 minus 1 plus x n, n varying from n by 2 to n minus 1. Okay. So, that is equal to x n w. Now, I replace this, say this is a 4-point sequence. You see, I take this value of n as some r, this n I replace by r by, so it will be x r w n by 2, okay, r is equal to 0 to n by 2 minus 1. So, n by 2 n r, is that all right? N is equal to 0 to n by 2 minus 1. What I okay, let me take a sequence, it will be easier. What I mean is x 0, x 1, x 2 and x 3 we take together. So, this will be a 4-point sequence, this will be a 4-point sequence. So, it will be x n into w. 4-point sequence, how do you compute? Originally actually it is clubbed with an 8-point sequence. So, out of that we are taking only the first 4 terms. So, it will be w 8 n k, but n varies from 0 to 3, okay. And then how do I write this one? It will be x n plus 4 and again n varying from 0 to 3. Is that all right? W 8 n plus 4 into k. So, that will be taking care of 4, 5, 6, 7. So, it is summation x n plus x n plus 4 into, it is x n plus 4 which gets multiplied by W 8 n k is a common term and W 8 4 k. So, W 8 4 k is the other term, n varying from 0 to 3. Is that all right? Obviously, W 8 4 k, W 8 4 is minus 1. So, in the first phase it will be just minus 1 to the power k. So, x n plus x n plus 4, x n minus x n plus 4. So, alternately it will be changing signs depending on k. So, x 0, for example, x 0 will be sigma x n plus x n plus 4, W80 is 1, okay, n varying from 0 to 3. So, basically it is now in the first stage. Oh, thank you, W8 nk, yes, W8 nk is a common term, okay. So, xn plus 4 and W8 nk, and when k is 0, this will be 1 and it will be just addition, and that is what we have seen. What will be x1, it will be xn, let me work out 1 or 2, then it will be clear, minus xn plus 4, and then see W8 1, when I put 1 it is W8 4, so that is minus, that gets multiplied by W8, how much, n, alright. So, you have to take this n is equal to 0, so that means if I write the terms like this, it will be x0 minus x5, when n is 0, so into 1 plus x1 minus x6, sorry, this is 4, x1 minus x5 into W8 1 plus x2 minus x6 into W8 2 and x3 minus x7 into W8 3, that will be giving me x1, okay. Similarly, x2 etc. will have a multiplier W8 2k and then again W8n. So, you can keep on doing it. Again you can break it down into two parts. This one, instead of computing from 4 points, I can go to 2 points and then combine them in a particular fashion. Now, I leave it as an exercise. You find out what will be the signal flows, the butterfly structure for this in the frequency domain, decimation in the frequency domain. So, for computer design, especially in FIR filters, we have just mentioned earlier, FIR filter specifications are given, say it may be like this. I may be interested in a filter where this is omega 1, omega 2, omega 3 and this is pi. This is 1, this magnitude is given something, it may be a straight line fashion, it may be normally in this region in a analog filter. In an analog filter, the transition is not mentioned, it is omega p and omega s which are of importance, but in FIR filter, if you are given a particular structure of the filter function, if you give me a spline function, say like this, or any other particular fashion sorry in which the transition should take place, then we can realize it, because we shall be taking in the computer design, we are taking discrete values, okay, these magnitudes are taken. Okay. Now, you scan this entire region from minus pi to plus pi, this will be an image, okay, minus pi to plus pi, this entire region into a large number of points, say 256 points. I may take more, and then take, what should I take? What is this? IDFT. All right. So 256 points you have got, say I will call it H0, H1, H2 and H255. These are the points. H0 starts from minus pi. So, so many points you have got. So, take IDFT. DFT and IDFT algorithm is same, okay, except that W will be replaced by W star. So, you apply FFT algorithm, you get Hn, and that Hn has to be then shifted by the number of steps that you want. So, that will give you the linear phase characteristics. FFT is very commonly used techniques. What about these points? They are all zeros. So, in that sequence, some of these points will be, initially it will be starting with zeros, also ending with zeros. Okay. So, you will get Hn. Sometimes we may be interested in a particular order of the filter, a particular order. I want this filter to be realized by a 9th order filter or maybe 10th order filter. Then what do I do? You choose some sequence H0, H1, say H9. So, there are 10 points. What are the best possible values of these to realize this filter? So, H e to the power j omega is H0 plus H1 e to the power minus j omega plus H2 e to the power minus j2 omega and so on, H9 e to the power minus j9 omega. Okay. And then you have got so many points. I need not have uniformly spaced points. I can choose large number of points near the transitions. Okay. Wherever there are sharp discontinuities, I take large number of points, and wherever it is flat or it is having a uniform characteristics, I take fewer points. Okay. You have as many points as you want, and then you go by minimization technique. All right. What you minimize is the got 1000 points, and we can write H e j omega 1 as this. Similarly, H at j omega 2 as H0 and so on, H9 e to the power minus j 9 omega 2. Similarly, this one will be H0 e to the power minus j omega 1000 plus H9 e to the power minus j 9 into omega 1000 and so on. So, this I can write in a matrix form. This is a vector, this is an information vector, these are complex quantities. E to the power h e to the power j 1000 omega 1000, and this side I get H0 up to H9, and this one will be e to the power j omega 1 e to the power j how much 9 omega 1. Similarly, last one will be e to the power minus j omega 1000 e to the power minus j 9 omega 1000. Okay. This is a matrix. Obviously, it is a 9 element in this row, and there are 1000 elements here. So, it will be 1000 by 9 vector matrix. This is a 9 by 1 vector. This is a 1000 by 1 vector. Okay. So, the solution is H vector, the optimum value of this vector. So, I will write the vector hat H hat will be, if I call this as some matrix, say okay, let me call it, what should I write, some matrix A, then it will be A transpose A whole inverse A transpose B, where B is this. When A is complex, it will be A star transpose A. Had it been a normal matrix, then the best possible solution for H is A transpose A whole inverse A transpose B. Okay. Otherwise, you take conjugate of A and then this. So, this will give you the elements of H. Thank you very much. We will next take up other forms of filters.